Good day to you. This is Anagalactic on a Friday, a continuation of the video earlier today where you see me in that frame. And here is our now familiar reference frame, mostly just to activate the geometric side of the brain so it's engaged, perhaps subliminally. Let's hope it's a little more to the surface than that because this will be pure geometry. What I intend to show you today has to do with that green line, the diameter. So that's one of the two lines you see, but you already know the radius and the diameter are directly related on a 2-to-1 ratio. So you can either use the radius, the Greeks preferred the diameter, you can use either one. And if you use the diameter to parameterize the circle, which you see there written in blue, that's a great circle that defines a unique sphere. We have the diameter both of the sphere, but in a different dimensionality, but it's also the diameter of the great circle. So the diameter is 2 radii. Why did the Greeks prefer that? You would have to ask the Greeks. I could tell you, but I don't think you care. They just decided the diameter was more fun. And since you're using the diameter to parameterize the circle, you have a ratio of pi, except it's inverse. It's 1 to pi, right? Because you want the diameter to be 1, because 1 then unitizes linear space so you can transfer linearity to the circle where it does not belong, and that's why it doesn't work. But you can approximate it, and there are thousands of books written on how the Greeks tried to do it and failed so horribly they gave up forever with geometry. It ruined them. They gave up. They could not figure out the circle because all they could get was a proof that pi is irrational. And that's the end of geometry as far as they were concerned. Well, it took 2,500 years to catch up with that hideous error of putting the 1 on the linear component. That's ridiculous because you're not in linear space. Why would you care about the radius of a circle? Isn't the circle more important than the radius? There's a reason for the unit circle, which I trust you do know that term. It is a circle explicitly with radius 1. Well, that's magic. You can then do magic with that 1. 1 is a magic number because of how it interacts with itself. 1 is the most peculiar number of all in a certain way of looking at things. So if you make the diameter 1, the circumference is pi. But if you make the radius 1, the circumference is 2 pi. Shouldn't that just be a unit number? Should it have a 2? It's too late to change. Science cannot fix itself. Science has no feedback mechanism. It can't correct its prior errors. And that's the death of science, as I indicated. There's several ways of realizing that science is now dead forever. There will be no more progress in science the way humans need science to progress. That has been forbidden by the United States government. The United States government will tell you what science is for. It's for them, exactly. Science is for technology, military, weaponry, and conquering the world. So that's what's going on now in the world, is science has been hijacked by an alien power, an inhuman power. If you want to say it's an angel, about 2 billion people, including myself, would say absolutely correct. You finally got it. Now what are you going to do now that you know that it is at least an angel that's doing all this stuff? It's no human, that's for sure. Well, where's the locus of control? That is perfect for an angel. You don't believe that? Goody for you. You must be so wise and proud of yourself because you don't believe in angels. Well, 2 billion people do, and I'm one of them. You want to come up against me? I'll teach you a lesson you'll never forget. But that's your introduction to the other side that science cannot address, but rational logic can. I've done so, but that's not what we're going to talk about today. I just wanted you to know you're in the apocalypse. Just gee whiz, I mean, it's a news item. You're in the apocalypse. Your generation will not live itself out. I like to bring that up just to keep things jolly and upbeat. But while we're looking at the diameter, what I realized is in the previous video, I just watched it again. I usually watch my videos 2 or 3 times after production because I learn from them. And I also catch my mistakes, and there's always something, you're never quite satisfied. Especially if you get a fact inaccurate, which, well, I'm human, sorry about that. But the reason the diameter is so important is that it traverses the entire space of the sphere. I'm just going to refer to the circle for now, but as you know, I make a very strict point of mentioning every time I mention either the circle or the sphere, they're the same. Now, of course, they're not the same. So why do I say they're the same? They represent each other. The great circle you see here has the angular momentum component on it. It's the integral of angular momentum is on the great circle. We call that the equator in the case of the Earth. Now, every sphere in the universe rotates, except the universe does not seem to rotate. I have the explanation for that, and that's what we're driving toward in this presentation, a follow-up to the previous one, where I had said that when you're looking at the moon, you can't find a straight line anywhere. And I thought about that. And I thought, well, there is one possible exception. Not just referring to the moon, but to any planetoid, really for instance, Mercury. Mercury is a planet because it fulfills all the requirements for being a planet. It is the one closest to the sun. But it's absolutely covered with craters. And you may wonder why Mercury is so pockmarked with craters without having broken apart. There is no real, of course, there's always a theory. Science is rather coerced into coming up with a theory when really what they should say is we have no fucking idea. There's no way we can figure that out right now. We're still working on it. Not when the government's telling you what to say, you can't say that. No, you have to have an answer for everything because you're know-it-alls, you're gods. You take the place of God or any church or wise man or real guidance. You have the government now, controlled by a fallen angel, of course. If you accept that, and if you don't, no one will ever care what you think. But those who do know are in the know. We just pity you because you cannot figure out the source of evil and you will die of it because you never figured it out. It's easy to figure out if you listen to wisdom. But of course, you're trained in the United States school system to reject wisdom whenever you smell it. And so you're possessed. That's just, I don't mean to scare you. Unless it does, in which case I succeeded. Because yes, I'm trying to scare you into wisdom, which you need right now, or you won't have it, and therefore you'll know nothing. And so you'll be a victim. You will be a loser. And what happens to you after that, no one will ever care. The only way you can become an object of care is to reciprocate what you expect for yourself. Just as the master said, you want to be loved, and if you don't, you're probably the next president of the United States. If you don't care about love for yourself, for your future, you need love, don't you? You'd better answer yes. You'd better answer yes to that. Unless you're the president of the United States, right? Exactly. Now you know the difference between good and evil. Okay, that's called Islam, right? And Christianity is a legitimate part of Islam. Don't you ever think that Christianity is overshadowed in any way by Islam. Christianity is the truth. Do Islam and Christianity contradict each other? Not in any way. They are absolutely coordinated. So whatever you were taught about Islam, you got it wrong. You hear it from me, you get it right. Those are your only two choices. Unless, of course, you go to the Islam scholars themselves and learn the way I did in 2025. I'm a little upset that that was kept out of my educational reach, although I would have to include myself in the blame, because obviously the Quran was there to read. I just was brainwashed against it, and I'm sorry. And I'm the one who has to pay for that, so you don't need to pity me. I'll simply face judgment. But I expect that Allah is merciful and beneficent, as we say every single day, because that is the ultimate truth. All right, so what about the diameter? I have a very interesting view of the Greek diameter. And I formulated a brand new theorem, which is now a new part of science, called the antipodal theorem. So I'm going to show you with this diagram using a handy dandy pointer, since I finally learned that technology. Here's your diameter. It's going at an angle to match the elliptically drawn great circle. That is meant to be a circle, but since this is a 2D projection, it looks like an ellipse, but you know it's a circle. So the diameter goes from one side of the circle to the other. All right, so now we're going to erase the screen. We'll just turn this off for a moment so you can do some visualization with me. Here is a line. How does it start? Take your pinchers. Take 3 fingers and make a pincher. Use your other hand, make a 3-pronged pincher. Put your pinchers together. There's a point. Why am I instructing you to make pinchers? So you can stretch the point. And that's the center of a circle. There's no circle yet because there's nothing. Your pincher is on a Euclidean point, meaning it's not there. But what is there is a position, which can be computed if you set up your space correctly. Euclid did, and I did better, because there are 2 ways to parameterize the plane. The way Euclid did, by stretching the line, which is what we're going to do, and the other way, which you're going to see visually now, if your visual onboard system is working. I pray it is. Stretch the line, watch carefully, pull, 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 all the way to infinity. Now your arms don't stretch that long, but your mind does. So now you have an infinite line. Now Euclid did not precisely do this. He really wasn't interested in infinity. What he was interested in is a line segment. So now we have a line segment inside a circle. Now watch again. Take your point. There's no circle, right? Now pull, pull, pull. What's happening? You're making a circle. You're generating a circle. Einstein never noticed that because Euclid never noticed it, and Einstein was too lazy or stupid to go back and check Euclid to find out why is he using straight lines to compute spherical relationships. Because he didn't know any better. There are 2 ways to parameterize the plane, and the circle is a planar object. So is a straight line. Here's something that might blow your mind. Those are the only 2 planar figures. Those are the only 2 planar figures. You can only do one of 2 things to draw on a plane. To make a geometric space, one of them is to pull the line to 2 infinities. That generates a space. And then you can systematize it with an orthogonal line, a second orthogonal line making 3D, and a third imaginary negatively signed axis to make 4D, and from that you can use a special form of calculus to create spacetime. So that's spacetime, and now you know what it is. In the mechanical sense of creating it geometrically. That makes pseudo-hyperboloidal space. A fancy-dancy term you don't need to worry about because nobody ever will except me. But the diameter now is very significant in the creation of the space because as you're creating a line, you're creating a circle. And which one is bigger? The circle is bigger. By how much? Pi. It's pi times the diameter. So that's multiplication coming into view. As you pull the diameter, you're increasing the circumference on a ratio with pi. So what's the quantum jump? The quantum jump off the non-existent Euclidean point. If it's nothing, it's not even there, it's 0D according to, I very often confuse Euclid with Einstein because I don't know, in my mind they kind of look the same. I don't know why. Well, I have some ideas. They both begin with E, they both have two syllables, but after that they're really not similar. So I don't know why I do that, but I do it a lot. Anyway, not Einstein, but Euclid. Euclid, what he did is he defined a point as being 0D, and then he defined a line as being 1D composed of points. And that has worked for 2,500 years, but that is woefully incorrect. It's superpositionally incorrect because superpositionally it's correct. And this drives scientists mad. We just discovered this new form of logic that the universe uses exclusively. It's the only form of logic that the universe uses. It's beyond us. We simply can't get used to it. I have. I'm the master of superposition now. My whole mind has changed to superposition, which is why I make at least one new discovery a day and have been doing so for over 1,000 days. So my cup overfloweth, but I'll tell you what, you don't want it to overfloweth too much because you get swamped. I'm finite, you know what I mean? So I'm giving you a lot of information in a condensed form because this is what I'm forced to do due to time constraints. So you pull a diameter, you're making a line, you're also making a circle. Now what I learned from that was how to compose the bootstrap theorem from the antipodal theorem. And these are my two original discoveries that I made in January of 2022, beginning with the antipodal theorem. You may not know what antipodal means. If you do, good for you. If you don't worry. It is the endpoints of a line. The endpoints of a straight line are the antipodes. But that's not how the term is used. It is now, and I'll show you. When you pull the diameter out, you're creating the circle, correct? Yes. So the antipodes refer to positions on the circle, not the line. So I was really technically incorrect by saying that the two endpoints of a line are the antipodes. But you can see with this construction that both definitions are correct, and that is superpositional. The center is also superimposed because, according to Euclid, the center point is the center of a line. Correct? But when you're making a circle, the point is the center of a circle. It just so happens they're the same point. So the origin of a straight line is exactly the same as the origin of a circle, which is why when you pull the diameter, you get the circle. What can we deduce from that that has everything to do with what I'm trying to show you so you have direct insight? Which is what? Which is that we have a new number system that's much better than linear numbers. Here's how I will show that to you. Geometrically, this is how I discovered it. So when you pull that line and it goes all the way to infinity, you can now say, although there's an abstraction involved, you can say hypothetically, that those two endpoints of the line are at polar opposite infinities, because you're saying that the line was drawn to infinity, which raises a serious question of what you even mean by that, because is that a possible point? Can there be a point at infinity? No. First of all, because there's no such thing as a point, but second of all, there can be no such thing as infinity until it's rationalized. And when you say that you're going to linear infinity, that makes no sense. That's a meaningless statement because of what the line is. The line cannot go to the end of anything. It has no end. It's an open line. And now what you can say, very technically, very mathematically accurately, is that the infinity in this direction is polar opposite of the infinity in this direction, which means the two infinities are related on polarity. That's geometric. What's the mathematical term for polarity? Valence, plus minus. And so we've adopted that, very useful for the line, only for the line, does not apply to force. But you'll see there are footnotes to all these things. we're coming to something that has to do with force, which is usually construed as a linear force, but does not need to be, because there's such a thing as a different kind of force that is a nonlinear force, such as, for instance, light, or for instance, gravity. All right, so when you're drawing this diameter, the circle that you're drawing may be a gravitational surface. It may be a gravitational field of a planet, and you're simply pulling the line out to the diameter of the planet to get the gravity at the surface. So you normally would just take one of those points. But if you go to infinity, you can say that whatever you say is there. It's positive infinity in the positive direction and negative infinity in the negative direction. And believe it or not, this is the absolute truth, so help me God, that is the definition of addition. That is the primary operator in mathematics, is addition. For this reason, because you can add two infinities so that they cancel, technically so that they balance on the center, which now has a specific constructed number in linear space called 0, and it has been proved. It took a while, but it was finally proved. You must have 0 in order to have the linear metric. Otherwise, there's no way to get to 1. So the center of a bipolar line, that is not a line ray, but a line in both directions, the double ray line, that is absolutely balanced on the Archimedean of the space. The space is the line, the Archimedean is the balance of the line, both numerically and geometrically, and Archimedes proved that. So I'm using that theorem that he showed is true. It's rather basic, but it's good to know. So now you have a completely balanced line to infinity. Now that means that at infinity, you have an infinite sphere, correct? We're going to say circle for the reason I gave. Very important to realize that whenever I say circle, it means exactly the same thing as the sphere on a constant relationship. It's actually a 2-to-1 relationship, as I'll show you, but that's specific to the unit sphere and unit circle when unit is constructed on the circumference rather than the radius. So the reason we're using the diameter is because it illustrates the polarity of the line. And when you realize that as you're drawing that line in 2 directions to 2 infinities, you're making an infinite circle. And so now you have an infinite circle. What's its value? Well, you can't answer that because you don't have enough information, but I'm just leading your mind in that direction. It's there, but it's undefined. For the same reason, infinity is undefined. Can we define it? Yes, we can. We can rationalize infinity in spheric space, that is, in circular space. In both cases, infinity can be rationalized because there are 2. And you may say 2, I don't see 2 infinities here. Check your line again and pull as before to 2 infinities. It's making a circle as it's making a diameter, right? So the circle is the product in some way of this bipolar expansion. So you have a 2 of some kind, because these are identical except they're polar opposite directions. But otherwise the quantity is the same on the line. The distance is the same. All right, that's so far so good. So in my antipodal theorem, what I state is that when you have these 2 antipodal points, but the circle is a special circle, where the edge is infinite, what does that say about the center? Because it does have a center. Now remember, with the line, all you have is a nothingness point. There's nothing there. There's no value. There's no quantity of any kind. That's a Euclidean point. And the one at the center is special because when you go in 2 directions, or even just one direction, you cannot metricize that line, so you cannot use it for distance until you put numbers on the line. And to put numbers on the line, you need an index, which is 1. But then you have to give it a specific length so that all the lengths are the same, and that's called the index of the metric. It's 1 of something, right? It could be 1 inch, could be 1 mile, could be 1 light year, but it's on the line. Well, if it's on the line, it has an end point, which is your distance. What's at the other point? It has to be 0. It has to be 0 for the linear center of the linear line, which is linear line, linear, linear, linear. It's a line. There's nothing else but that line. And so the two infinities add to the center of the system. The system is the line. What about the circle? We have a circle that's expanding with the diameter. So they're directly related on a constant, although it's an irrational constant called pi. This is why pi is such a significant irrational number. So we have now a circle which is defined on an infinite line, which means the two infinities of the antipodes add to 0, right? For just one line inside that circle. What if you do that for all the lines at once? In other words, the radial line, which just means it comes out in all directions, just exactly the radius, but it's all the radiuses integrated. It's the integral radius. Can you compute that? Yes, you can. It's a very easy computation. And we'll get to that, but I just want to tell you the nuts and bolts of what I'm doing. This is extremely simple. This is as simple as mathematics can get. And we've already encountered add. We have seen multiply because that's how you get pi onto the circumference, is by multiplying the radius by that number. Because since the radius is 1, then you get a direct proportion, which is pi, which is about a little more than 3 times the linear length of the diameter is that semicircle. It has a distance, if it could be computed, which it cannot be unless you use calculus and cheat and lie, which is what science has done ever since, and just say that's a quantity, just as the diameter is. That's a fib. But it does work if you're very careful about infinitesimals, so that you never say you can get an exact number for an infinitesimal. You can't. It's always irrational. All right. So that's a lot of information. You may object. Leave a comment if you want me to explain or you need to challenge that. That's perfectly part of science. Every scientist welcomes a question if you need one so that I can explain further, but I can't dally on details. So the antipodal theorem states that the infinity that you made is that circle. So that circle represents infinity, which is a boundary. For the simple reason that infinity has a characteristic that it doesn't have a boundary. And so we're artificially suggesting, that is, this is a hypothesis, which then will have to be proved because this is going to be a mind blower. We're going to say that that is the actual universe. That is what the universe is. It has this boundary, it's finite. And beyond it is a very special space at the boundary. And the universe, in order to be computable, has to be finite. You may find your mind racing there. Ask questions if you need to, but this has been proved. So these suppositions are leading up to a direct insight which you're just about to obtain. You have a boundary called the edge, which we're now saying is an infinity. Okay, good. Now what does that do for us? Well, it gives us an apperception. You might wonder, does this have any value? That's what I'm going to show you, but first you have to at least try to imagine that it could be true in some way. Very difficult to do when you don't already know the proof. So that circle, based on an infinite diameter, has a surface that is the boundary of the universe, and that's the edge of the universe. That is the edge, and there is what is beyond it. It has to be quantified in some way, but you can't do so linearly because you can't add that infinity to any other infinity. There's no other infinity to add it to. On the line, there are two infinities that are related polar. They're polaric. They're at opposite ends of the line because the line is open. The circle is closed, so it does have an interior. So what we need to do is define the interior with respect to the exterior. And this is an ancient problem that comes up in several forms. If you're trying to finitize infinity, what then do you do with infinity? You can't throw it away. It's much larger than what you're measuring, if it's indeed the same. We're not going to say any statements because we're going to get a direct insight into what that infinity is, based on the fact that the open line, that is the line with no curvature, what's called the Euclidean line, which typically we call the straight line, that has two infinities that are related on 180 degrees, as we put it. That's called polar opposite, and that means the two infinities add to zero. So that is the linear extent of the finite universe. It can be measured. It hasn't been measured yet, but I will show you how to measure it for the first time, that I can measure it. This can be done. But it leads to unlocking several secrets of physics as you do so, and that's what we're getting to. So now, instead of having two polar infinities that add to zero, what do we have? We have a circular infinity that is outside. What do we have inside? Is there a relationship between what's inside, which by definition is finite because there is an edge, so it can be measured, but then what's on the other side of the finite universe? Very interesting mental gymnastics you might execute to try to figure that out. Don't try too hard, because nobody in history ever figured this out except me. So I'll just give you the answer. Instead of using add on the two infinities that you can see, you have to do something else. You have to use a different operation to correlate two infinities, but we've only found one. Is there another infinity? Yes. And in order to see that, we need one more diagram, which I will now put up on to the screen. And here is our next diagram to assist us in the computation that we wish, actually a correlation of two infinities. You may have seen this from some of my prior video presentations, but in this context, this will give the full justification for why I love this particular diagram, which was not composed with my aims in mind, but it just turns out to be ideal. We have three concentric circles, with the usual center right there, labeled O for origin, and then we have a metric for the advancing radius, which goes to the first circle 1, the second circle 2, and the third circle 3, the outermost of which has a radius of 3. Now, what we're going to do now is simply use the simple transform that I taught you, which every mathematician is very well acquainted with, called a multiplicative inverse, where you have here the red circle has a radius of 1. So that's the unit circle. Practically worshipped, but I don't want to use a trigger word. That is the unit circle. What we're going to do now is deunitize it so it's non-Euclidean. However, that's illegal. We have to have Euclid because we have to continue Euclidean geometry. It has to be permanently available. Why? Because it's consistent, except for certain features which we're now going to overcome, so the inconsistencies in linear space disappear. So that's quite a tall order. How do we do that? A very simple step to begin. You have the unit circle there in red. So that means that the circumference is tau. It's 2 pi. Because we're using the radius, not the diameter. Okay, so you know that. So it's 2 pi all the way around that red line. So that's the linear value of what would otherwise be distance, although this is not distance, it's something else. But if you're going to measure it in distance units, the value is irrational, it's 2 pi. Now we don't want that. We want the rational number, which is 1, to be on the circumference. So how can we do that and still know what the radius is? I think you know. What you do, since the formula for the circumference is 2 pi r, and r is 1, therefore the formula for the circumference is 2 pi. And that only holds for the number 1 for the radius. It's just convenient. Although it is consistent with all other radii, the circumference of the second circle going out, whose radius is 2, that obviously would be then 4 pi. Am I correct? I believe that is double the value of 2 pi, so that would be the circumference of that circle, and you could measure it if you wish. But that is true. So what we want to do is put all the irrational numbers onto the radius for each circle, beginning at the unit circle, because that's the simplest. So what's the value of that radius? It's 0.16, approximately. It's the inverse of tau. So when the radius is the inverse of tau, then the inverse of tau times tau is 1. And that's the circumference, is 1. So when you want the circumference to be 1, you want the radius to be irrational. And that's what we just did. A very simple step, absolutely sanctioned and condoned, just blessed by all scientists. There is nothing funny business going on here. It's a simple mathematical transformation based on the simple step. It's not a trick, it's just something, it's a transformation that's legitimate in multiplicative space, which this is, okay. So now we have these numbers that used to represent the radius, now represents the circumference in the case of the red circle. In the case of the circle that now has a circumference of 2, this is not drawn to scale. And the circumference of 3 is again not drawn to scale. What would happen if these were relabeled with a radii? The inner one would be 0.16. What would be the radius of the second one? Would it be double that? I'll leave that to you for homework. Perhaps this is drawn to scale. I actually haven't worked that out. Well, that'd be a good exercise, but we'll skip it for now. Leave a comment if you'd like to see that presented on the screen, assuming I get it right. But I believe you could just say this is either to scale or not to scale, but we're not really concerned with that. We're only concerned with maintaining the consistency of relationship. Whether that means redialing. So if the radius were actually 2 times its former value, which it is, well, would it be? That's the question. So if the circumference is 2 and the relationship is 2 pi r, well, now you have 4 pi times the radius to do the computation in that direction. But if you're doing the computation in the opposite direction, where the circumference is known, but you need to extract the radius, will the extraction of a circle with value 2 on the circumference, will that indeed have a radius of twice the inverted unit circle? I believe it would have to. Am I missing something? You see, this changes subtly when you switch to the sphere, which is why I think I delayed this computation for so long, because I've been having, well, historically, the difference between computing the inverse of the unit sphere, which is a radius of 1 on a sphere, not a circle, the formula changes to have a squared quantity in it. It would then be the radius squared, which really is a bit tricky, I'll just say. But in any event, I'm just going to assert that this is probably correct the way it's drawn, but it doesn't matter much. All right, anyway. Well, that really has me going now. But I don't want to delay this sequence because this is the most important sequence I've been presenting so far. So now we have a circle whose circumference is 1. Now, for the time being, I just want you to disregard the other circles, and to make that a little bit simpler, there is a single circle, and that is now our unit circle. We're just going to say so, because it's just any circle, and we are deciding what kind of a circle it is. I believe that is a fair thing to do. I'm just going to adjust this just a little bit so we can see it slightly better. And there is our diagram for the inverted unit circle whose circumference is 1, meaning that the radius is 1 over tau. And there is our inverted unit circle with a value on the circumference of 1. Is that correct? Is that in the right form? Because now we're talking about a planar figure, not a line. Do the rules change here? Can we say that that circumference is indeed 1? We can on a well-known reduction. The actual value of the circle cannot be a linear 1, because a linear 1 only makes sense on a straight line. So it can't be a linear 1. You can't write it that way. This is part of my discovery, by the way. You have to write it as a fraction, because a fraction represents a rate. And in this case, the fraction will represent the rate between x and y on a closed line. And that rate is 1. But a rate is never written that way. A rate is always a fraction, because it's a comparator operation between two linear quantities. And in this case, the two linear quantities are vertical and horizontal. And so the vertical and horizontal being orthogonal, if the circle completely encircles the center point of that two-line system, then you can use two linear numbers in combination to represent the closed line. And that is called the rate of the circle. It is not a distance, although it has a distance component in it. So now we have the actual value of the world's first planar figure that actually parameterizes the plane, because Euclid failed to do that. He could not parameterize the plane. And I must be more specific, because this is absolutely the perfection of superposition. He did get it right, but it has to be defined explicitly by Euclidean axiomatization, whereby the 0 at the center of the line has a very specific meaning, as do the two infinities. In the case of the circle, what we have now is the ability to divide space into two parts, which the Euclidean system cannot do until you get to the cube, in which case you could say that the cube is a closed figure. It's called a closed rectilinear figure, and it is the perfection of rectilinearity because it's a cube, which means it's 1 on all 3 vertices. It's 1 on all 3 edges, which of course is duplicated on the other side. And you can use Euclid's rule to figure out the number of vertices, faces, and edges using a very interesting formula we don't have time to go into, but you can look into that if you're interested. It's worth knowing. Now, what we're looking at here is the innermost of those three circles, which now becomes significant, because inside this circle is one space, and outside the circle is another space. And that space outside the circle, you may recall, and I think you do recall, that the outer circle here is the edge, it's the edge of infinity. So this has an interior, and now this circle has an exterior. So in between this circle, the invert unit circle, and this circle, which here should be labeled with a different number because 1, 2, and 3 don't apply here, this is the edge of the universe. Well, what is this? Well, it's a circle inside the universe. Okay. And it has a value of 1 over 1. Okay. So numbers that have a 1 in the denominator can be reduced to the numerator value, and that is called reduction. It actually changes the shape of the number, though. A feature of that operation which is just conveniently never mentioned. Oh no, 1 over 1 equals 1. Yes, it does. And we're just going to accept that because that is true, but I want you to know the footnote to that. The 1 over 1 is not written in the same form as a single component 1. The 1 over 1 is two ones in relation, and the relationship between 1 and 1 is 1. And that's the magic of 1 right there. You just saw it. The value of a two-component 1 written in fractional form is identical in value with just 1. So a two-component 1 equals a one-component 1. What's the difference? A one-component 1 jumps from the center as a radius. A two-component 1 jumps from the center to the surface in all directions at once. It's a rather cumbersome phrase to have to add at the end, and there should be a better way of saying that. There is. That is the radial radius. It's not the linear radius, it's the integral. So that is the value at the surface of the radius, not the linear radius, the actual radius of the object. That is not a straight line. It is the integral of all the radii. It's the integral of the linear one into the two-component 1. And that is called a rate. A rate between what and what? You may be reminded of something that has a ratio between one quantity and another quantity, perhaps light speed. Yes, it's distance over time. So there is a possibility to compose, for instance, light speed is not a one-component number. It's written in a completely different number system. Not completely. This is what confuses us. It has for 2,500 years, so don't expect you're going to get through this easily. The 1 on the circle is a two-component rate number that has the value in linear terms of 1, and that you can take to the bank. That 1 over 1 equals 1 in value, not in geometry. 1 over 1 is not a number you can apply to a line. A line does not have the principle of division built into it. You cannot divide the line using division unless you cheat, which is how we were taught arithmetic, is by doing it wrong. All right, and the reason for this draconian pronouncement on a 2,500-year-old geometry is because it forces you to the use of 0. And 0 only works with add. It does not exist in the higher number form. A two-component number cannot have a 0. There is no 0, and I'm going to prove that to you with pure geometry. You're now going to see it. So this circle that's in red is we're going to say it's the center circle. So we have some reference circle. That's our reference frame. Yes, it is. Our reference frame is no longer based on 0. The reference frame has shifted from the center, which is no longer the reference frame, and I'll show you why in a moment. The new reference frame is the circle itself. The reason is it divides space into two parts that now can be correlated mathematically. That has never been done. I will do it for you now. This is called the conjugation of infinity, and I call it the bootstrap theorem. The way this begins, using this diagram, this will be a little bit new to me to use this diagram to explain this. This can be explained in several, I'll just say, avenues, because you're going to encounter a very interesting and challenging proposition. That the finite edge of space, which we are saying must exist, otherwise you can't define infinity at all. It has to be something beyond an edge. So we're saying that's the outer circle. That's the edge. It's finite inside, but it's infinite outside. So the outer circle is the dividing line, and it is a line. A straight line is a kind of line, but a circle is a true line. It's a closed line. It's a perfect closed line. It's closed because it has an interior. That explains the universe. So this is absolutely correct. And Euclid is left behind. He's not left behind. I proved in the antipodal theorem that the circular surface in this case, which translates to a spherical surface for the entire universe, the edge of the universe, we can now envision it. On the other side of that sphere is infinity. And what's inside is the opposite of that. It's finite. It's finite to the edge, beyond which it is not finite any longer. So that is the limit of measurability. The limit of measurability in the physical universe is the definition of that circle. It is the universe, goes to that edge. Now, that is not directly provable until you have a direct insight into how this affects inner space. So that, in this diagram, you see the universe that has two concentric circles inside of it. So the outer circle is special, and it has to have a special value because one side of it is different from the other side. So the metric is different. Once you reach the edge, there's a transition into another domain. And we're going to leave it at that for now because we have not yet gotten enough information to conjugate this infinity with another infinity. We did so with the polar infinities by discovering add. We discovered that we can give a valence to the two polar infinities such that they add to the Archimedean. In this system, the Archimedean is not 0. The Archimedean is that red circle, and that's where space ends going in. There is no space inside that circle, and that is called the quantum of space. That is the quantum of space, is that circle. That's the geometric representation of the center of the universe. You will have an objection, every man has. We'll get to the multiplicity of centers in a moment. But for this one center, call it an arbitrary center, but it's one of the centers that you can use as the center of a system. And if you begin metricizing your system by pulling that diameter, you're making the circle. Where does that stop? Well, it doesn't stop until the edge, right? So can you measure from the center to the edge from the inside? No, because there's no space. There's an absence of space, and that's the true zero. It's the interior of a quantum is zero for all practical purposes. However, I'm going to show you that geometrically it can be shown that there are numbers inside that circle. And the reason is that the surface value of the smallest of all circles for space, being 1 proportion 1, makes the unit number 1 for the circumference. Now, if you go out, you can then generate a circumference of 2, and then you can keep going out by simply increasing the numerator. But if you are wondering what happened to the numbers less than 1, aren't there numbers less than 1? Yes, there are. In binary space, there certainly are. There's an infinite number of numbers inside 1, 1, beginning at 1 over 2. And then you continue inward. But now you see a problem, because to the proportion that you're doubling the number going out, if you're using binary, this is your simplest, so that you go from the surface of the inner circle, which is 1, you go to 2, and then 4, and then 8. And that's called a geometric progression. But going in, it contracts in the opposite circular direction, which has the inverse metric, which is 1 over 2, 1 over 4, and now you see Zeno's paradox, which can now be solved. So Zeno's paradox going in is when you have the distance and have it again and have it again, you never reach 0. It's an asymptotic relation, so there is no 0. So it can't reach the center that way. Okay, that means that the center is absolutely imaginary. There aren't even any numbers less than 1 that can get to the center, to the proportion that no number greater than the biggest number can get to infinity. And that's the limit of measurability going out. But now you see there is a reciprocal relationship between the two infinities, such that as you jump simultaneously in both directions, this number gets smaller, that is going in. It goes to 1/2 to the proportion that this circle is 2. This goes to 1 over 4 toward the center. This goes to 4 towards the edge. They meet at infinity and cancel on multiplication. Therefore, the center of that relation is 1 over infinity, and that's the value at the center, is 1 over infinity. So that is an infinity, as was suspected all along. 0 in linear space is an infinity in physical space, and that is a physical, unreachable point. That point cannot be used. It's not there in any way, no matter what your mind tells you. However, your mind does tell you that there is something there because you can see its position. Its position is 1 over infinity, and that means its relationship to the edge is that number. It's the unit of distance to infinity. So if you could reach infinity, it would be with numbers whose unit basis is 1 over infinity. So if you can count all of the 1 over infinity numbers that go to infinity, you would have an infinite number of those numbers. If you're trying to measure infinity, you have to stop where measurability stops. And that is that outer circle has to have a specific value where the system changes. to include infinity because it's there. Well, now it's really there. It's the inverse of 1 over infinity. So the edge of the universe now has a value that can be computed. It's infinity over 1. And the reason that is consistent is because the two infinities, which used to add to 0, now multiply to 1. And that means that the red circle is the center of physical space. I will show you in the next video that that's also the center of time, which is already known, but it's misrepresented in linear mathematics by Albert Einstein himself. So he got it wrong. And I will now show you the right answer, which leads to every solution, including the unified field solution. You will learn the quantum of gravity, you'll have all the answers. You won't be fooled by the Big Bang anymore. And then very soon, I will return to the Grand Canyon, the Colorado Plateau, the Himalaya Mountains, and the Antarctic Peninsula, so you know where you come from. Because if you don't know that, you're missing out on a lot. So I'll give you everything you need. Stay tuned and keep looking up. We're approaching the new moon, the end of Ramadan, the holiest time of the year for 2 billion people who are about to be wiped out by Israel. And nothing will stop that. If you care to know more about that, I have the answers there too that will soothe your soul and get you into heaven anyway. You don't want that? You're just a typical lazy fucking American and I hate you. And that's to save you. Maybe my hatred will wake you up. Stay tuned. We'll be right back. Thank you very much for everybody who tunes in. It means a lot to an old dying professor to know someone's listening. Thank you for your comments so much. We'll be right back.